Okay, so maybe today I'll be a little bit more structured and not be all over the place. But maybe I didn't scare you too bad yesterday. I was in a I don't know, a trance. So we talked about this part, right? Did we talk about initial side and terminal side? We're beginning every rotation on the positive x-axis. So this is going to be your initial side. And then we rotate counterclockwise. That's the normal rotation. And we're going to rotate to some terminal side. So they've got all kinds of vocabulary. Angle, vertex, initial, terminal, measure of an angle. Oh, and then standard position. All that standard position means is that the angle is formed at the origin. Right, the vertex of the angle is at the origin. So not a lot of exciting stuff there. And then here they talk about the 4 different quadrants, 1, 2, 3, and 4. And they talk about 360 degrees makes a full rotation. They talk about positive rotations. Positive means you're going counterclockwise. And a negative rotation means you're going clockwise. Okay. Okay, here's something new. This is something we did not talk about yesterday. Coterminal angle. All that coterminal angles are, these are angles who have the same terminal side.
So 410 would be the same as 50? Negative 210 would be the same.
So, for example, if you were to rotate 90 degrees, that's not the only rotation I could do that would start me here and end here. What other rotation could I do that would get that same result? 450. So if I did 360 and then did another 90, that puts me in the exact same position. So 90 and 450 would be considered coterminal.
So number 1, 410 is...
Also, I could rotate negative 270. That would also be coterminal. Okay? Anything that ends at that same terminal side or ending side. So how can I find all, or are these the only 3 that are coterminal? No, I can keep finding more. How can I keep, thank you. How can I keep finding more?
Add 360
or
subtract 360.
That's it. Adding 360 or subtracting 360 will find you all of the coterminal angles. So, any questions about that? So now let's look at this example. We've got an angle that's 50 degrees. We want to choose out of the 4 beneath it, which of them are coterminal. Okay, so if I started with 50, I would just start by adding 360. That would give me 410. Is that a choice?
Yes.
Are there any that are higher than 410?
Yes.
There are, but are there any choices higher than 410? So there's no point in me keeping adding 3. I shouldn't keep adding 360. So now let's subtract 360. That would be negative 310 degrees. Are there any lower than negative 310? No. So those are the 2 that are coterminal. Questions there. Next question. I've got an angle that's 1,366 degrees. I want to find the coterminal angle that is between 0 and 360. So that means I've gone too far right now, right? I'm at 1366.
So minus 360.
So subtract 360. That gives me 1,006. Is that between 0 and 360? So I subtract 360.
Approximately 280.
What do I get if I subtract 360 again? That's 646.
I think it's.
I'm doing it in my head. Nobody going with me?
I think we should just do 7 and get 280.
646. That's still too big. So subtract 360 again. 286.
I'm locked
An
in.
angle in standard position is simply the length of its intercepted arc on the unit circle. That's you won't ever hear me use that kind of terminology. That's too fancy for me. 1 radian, abbreviated 1 RAD, is the real number 1 without any dimensions. So again, that's what I was mentioning before. They don't have any units. They don't have any dimensions. That makes it easier to do calculations with radians. To find radian measures of angle alpha in the standard position, find the length of the intercepted arc on the unit circle. If the rotation is counterclockwise, the radian measure will be positive. If the rotation is clockwise, the radian measure will be negative. Same stuff we've already talked about. A radian measure is called a direct length because it's positive or negative, whatever. We know the circumference of a circle with radius r is... How do we find circumference of a circle? Does anybody know the formula? C equals... So it's pi times the diameter or 2 pi times the radius. Where's the 2 pi coming from? The 2 pi is an entire revolution times the radius, right? From the center to the edge. There are 2 pi radiuses in a circle. Do you guys know what circumference is?
It's
Like what's its equivalent?
It's the distance around a circle.
Distance around a circle. It's like perimeter, okay? Circumference is the same as perimeter. Except how do you find the perimeter of a polygon?
You add all the sides.
Okay, well, add all the sides of a circle. Exactly. So circumference is perimeter. They're the same thing. It's the distance around the outside.
Wait, I saw a video on TikTok where this guy, he made this circle, he cut up it into a bunch of pieces and it turned into a square.
Okay, what do we know about the unit circle? There are 2 statements about the unit circle we have to know. The unit circle is centered at the origin with a radius of 1. So the unit circle has a radius of 1. So if you plugged in 1 for r, what's the unit circle's circumference? Just 2 pi. 2 pi times 1, which is 2 pi.
Okay, so that's what it is.
If an angle rotates a full circle, we know it's 360 degrees. The length of the intercepted arc would be 2 pi. We can express the relationship. So there it is. 360 degrees is 2 pi, or 180 degrees equals pi. That's the more important one. That's the one you'll use more often. So we're going to go over how to convert between the two, but eventually you're going to have to know, memorize, be able to discover pretty quickly what some of these are. So like for me, I know without doing the calculation, I know the answer to A, C on both of them. Okay, thank goodness that was you digging in your backpack. I heard that little rustling and I thought, is that a rat? Please don't be a rat. Please, no rat. I don't think you're a rat. That's not my point. My point was I just heard the little noise. And I was like, oh my gosh. I was putting together Noah's swing set in the garage, and I heard that rustling just like that, and there was a rat come running out. I cracked the garage. I was scared to death. I was like, get out of here. I didn't blame it. It was cold. Okay. So here's how we do a conversion. 270 degrees. I want to know what is that in radians. So I'm going to say 270 degrees over x radians is equal to, and then what's the ratio that I do know? I do know there are 180 degrees in pi radians.
So every 90 is going to be 1/2.
Yes.
So you could do 1.5.
Yes. If you can get there, that's fine. I'm going to show you the calculation behind it, but you're correct. You're not wrong. So if I do this, I cross multiply. I've got 180 times x equals 270 times pi. You're okay with this? I know I kind of just did this quickly. I'm setting up a proportion, and I'm solving for x. If I divide by 180, then x is equal to 270 over 180, which is 3/2. So 270 degrees is 3 pi over 2.
Yeah, that's not on there. Oh.
What's 35?
I thought it was one of them.
No, it's not matching.
Where you draw the line.
It's not matching.
Yeah, I like that
3 pi over 2 radians.
because it was 1.5.
You guys try C. Skip B for a second. B's going to be an ugly, ugly number.
So,
I say that. It may work out okay, but
what?
see if you can do C. What's 210 degrees?
You just put. So you basically just switch. Get rid of the.
Okay, so
There's only one thing that's going to change from what I did.
Yeah, you.
When you're going to set up the exact same way, it's not going to be 270 though.
what's 180 divided by 30? 6. So 1/6.
What if a calculator needs to be used?
It's 7.
My brain power is the strongest.
So good. Are you doing B, Craig?
No, I'm unity tied there. No, my calculator froze.
Negative 23.6 is going to grind my gears.
You won't grind my gears.
Wait, can you do it on your calculator like that?
You can just do a fraction.
Yeah, I mean, you're going to be able to do it in your calculator. So this gives me 180x equals 210 pi.
Yeah, no, that's not.
So x is going to be equal to 7 pi over 6. Is everybody okay with that? We need to show somebody, help somebody. Let's go ahead and do B. B's going to be ugly.
It's going to be harder.
B is going to be about.
Let's see what we get here. We get
It's going to be less.
negative 23.6 over x equals 180 over pi.
Like, can we convert negative 23.6 to a whole, like, to a positive number?
Can you do what?
Can we do that? Is that right?
Can you do what?
Convert negative 23.6 to a positive
No.
number?
Keep it negative.
You just keep it like that because it gets so ugly.
Nope. This should be an okay fraction.
Yeah, it is. It's just really ugly.
I get negative 59 pi over 450.
I'm out. I'm sorry, Phil.
We're good with that? Let's go the other direction. What if I start with radians and I want to convert it to degrees? Well, you're going to have to do something completely different than what I've been showing you. I'm just kidding. 7 pi over 6 is my radian measure. And I'm looking for what? I'm looking for degrees. So for me, the way I set it up, I know the radians, I'm looking for degrees. We just have to make sure we make the units match. So if this was radians over degrees, I have to keep it as radians over degrees. So for me, that would be 100, that would be pi radians is equal to 180 degrees. Again, if you want to set it up the exact same way, you could. Like, you don't have to flip these. If you kept degrees on top, radians on bottom, you would still be fine.
I think I got A and C, but I really don't know how to do it.
Cross multiply. So pi times x is equal to 7 pi over 6 times 100. That should be 210 pi.
It was on number C on this one.
Yeah. Divide by pi. So x equals 210.
Wait, what'd you get?
Jackie, on our paper, look at 210 equals 7.
Yeah, we kind of already did that one.
Yeah, but how did you get that?
All right, Jackie.
So from here, cross multiplied, right?
7
Pi times x,
7 over 6 times 180.
7 over 6 times 180. So 7, what I did 180 divided by 6 is 30. 30 times 7 is 210. 210 pi.
And that always works.
You divide by this one, multiply by that one. Though I can do it in my head. You can go the other way. You can do 180 times 7, but that was too big for me to, I didn't want to do that.
Jackie,
So I did 180 divided by 6, and then times 7.
what I did 5/3 is, so that's 4, that's 5/3 of the turn. You know what I mean? Yeah, bro. So 180 plus.
Bro, just put the fries in the bag.
Can I, is everybody okay with this, how you actually set it up and do it? Like doing it this way? Can I show you the way I would do it? Because you're going to have to get quicker at doing some of these, like I said. Like I can do A, C for both of them quickly. Like I don't have to do these steps. Because like they're the ones that are on the unit circle.
Yeah.
That either you have to have memorized, or here is the way I think about them. So I'm thinking of the fractions. So when it's in radians. So like if it's some number over 4, some number over 3, some number over 6. Okay, those are the quick ones. Like either 1 pi over 4, or 3 pi over 4, or 5 pi over 4, or 7 pi over 4. Whenever I see over 4, I know that I'm working in 45-degree increments. Okay? Because if you think about it, you're taking 180 degrees, dividing it into 4 equal parts, right? 45, 90, 135, 180. So, for instance, if I saw 7 pi over 4, that means I have 7 45 degrees.
So it's 135 plus 180.
You could think of it that way. This would be 315. Right. So you heard the way he's like, there's a bunch of ways to get there. Like you don't have to do the same mental math I do.
45 times 7.
But here's the way I think about this one. Okay? 7 pi over 4. That's very close to 8 pi over 4. It's one away. What is 8 pi over 4?
2 pi.
That's 2 pi. 2 pi is 360. But I'm 45 degrees short of 360. So 360 minus 45 is 315. Okay, that's the way my brain gets there. Let's do another one. If I did 3 pi over 4.
You're 45 away from 180.
I'm 45 away from 180, right? I'm 45 away from 4 pi over 4, which means I would do 180 minus 45, which is 135. 5 pi over 4, I'm 45 past 180, right? I'm just past 4 pi over 4. So this is 225.
This sounds like.
That, again, you don't have to do it that way, but you need to come up with some way to do it kind of quickly. Right? When I'm over 3, this is 60 degrees. Right? Because I'm dividing 180 into 3 equal parts. So for instance, if I had 2 pi over 3, that means I have 2 60 degrees.
So you got 140. So it's like hours. You got weight room. You got hours.
5 pi over 3. 300.
Because you
I'm
almost.
60 away from 6 pi over 3.
Which is also.
And then the ones that are over 6, these are 30 degrees. Right? That's the same thought process. So like 7 pi over 6 means I'm 30 degrees past 180, which means I'm at 210.
So you just take that,
7
if it's over 6, you say 30 times 7. That's your answer.
Yes.
7 times 3.
Well, you could do that with any of them. You could multiply them. I'm just trying to do it without having to multiply. Because like, if I got 11 pi over 6, you could do 11 times 30 if you wanted to. But that's probably not super easy for some of y'all to do in your hands.
That is really, it's.
Well, fine. Whatever. 330. Just give me a brain.
That's
I'm trying to explain to you how my brain
I
works.
can get it if it was like 11 times.
I got it.
I got
it. And let me. What's weird about the 12.3? It doesn't have pi in it. Right? It's just 12.3 radians, not 12.3 pi radians. And people will think that this is wrong. That they think it can't be radians because it doesn't have a pi in it. It can. Remember the way that we first looked at radians. We could rotate just 1 radian. That was very normal.
That's a lot of degrees.
Well, that's why we're fixing to figure out how many it is.
12.3 divided by pi.
12.3 radians. I want to know what is that in degrees. That's going to be equal to pi radians over 180 degrees. Cross multiply. So I've got pi times x equals 12.3 times 180. I don't know. My brain don't want to do that this early. 12.3 times 180 is 2,214. And now divide by pi. So I could just leave it like this, actually. It would be 2,214 over pi degrees. If you wanted to get the decimal, you would get approximately, so it's about 704. What do we get? Sorry, I'm running out of space. It's approximately 704.76 degrees. So now, this is coterminal again. So what did coterminal mean? It has the same ending line. How did we find coterminal angles when it was in degrees? We could add or subtract 360. But we're not in degrees, we're in radians. So I wouldn't add or subtract 360, I would add or subtract 2 pi. Because 2 pi is the same thing as 360 degrees. So for the first one, I've got 43 pi over 10. And I need to subtract 2 pi. So what am I going to have to do if I want to subtract these? I'm subtracting fractions.
You gotta make the bottom.
Put the 2 pi over 1, and I need to get a common denominator. You can't subtract fractions without a common denominator. So 2 pi is the same thing as 20 pi over 10. Does everybody know how I did that? I just multiplied the denominator by 10 here, which means I had to multiply the numerator by 10. So if I subtract these, that's going to give me 23 pi over 10. And that's still too big. So I need to do what? I need to subtract 2 pi again. 2 pi is 20 pi over 10, which is 3 pi over 10. That's between 0 and 2 pi.
36 times 3.
That's it. That's the answer. It's 3 pi over 10.
Is it not asking for degrees?
It is not.
But if you were looking for degrees, 36 times 3.
You'd have to do times 180 divided by pi to convert it. But it doesn't. It tells me in radians. So I want my answer in radians.
Yeah.
Okay? Questions? The next one. Where is 120 pi over 7? It wants to know what quadrant is it in. So if I were to rotate.
So,
Oh,
straight down, very straight.
So for me, that's way too many rotations to figure out where it goes. Like, I don't want to rotate that many times. So what I would do is I would find a coterminal angle that's closer to 2 pi so I can figure out where we have to rotate to get there. So I'm basically going to do the same thing I just did by finding coterminal angles. So let's start by writing my original. And then to find coterminal, I need to subtract 2 pi.
14 minus 14.
This time, 2 pi would look like 14 pi over 7. So I could do this. I could do this a bunch of times, okay, to try to figure it out. Can I show you my lazy way? Like, this is fine. You can keep doing this and subtract 14 pi over 7 and subtract 14 pi over 7. But I'm going to have to do it a bunch of times to get down to one I like.
112.
So what I would do is I would just go ahead and do this 10 times. So if I subtracted 14 pi over 7 10 times, I'm essentially subtracting 140 pi. Right? I'm just multiplying by 10.
I don't want to do it that way.
I do. I want to because I'm lazy.
But it's easy.
There's other ways you can do it, but this is the way I would do it. If I subtracted 140 pi, that leaves me at negative 20 pi over 7.
Which would be
Which now, that's very easy for me to get to where I need to go. So I could, if you wanted to, you could add 14 pi over 7 back to it. Right? Huh?
Why don't you do minus 112? That's divisible by 14.
No, because people don't know that. Like, I don't know 112 is divisible by 14. Do you? I mean,
Well, 14 times 5 is 70,
Uh-huh.
plus 28
That's
is
fine.
98.
I know how you got there, but I'm just telling you. Hey, the people around you don't know that. They don't know 112 is divisible by.
So why don't you shut your mouth, buddy?
Yeah. You can do it that way, right? It doesn't have to be done the way I'm explaining it. But now that I'm at negative 6 pi over 7, I know where that's at. Like, I can get there. Because what would negative 7 pi over 7 be? Negative 7 over 7, that's just negative pi. So if I rotated negative pi, that would put me
180.
here at 180. But I didn't quite rotate that much. right? Only did negative 6 pi over 7, not negative 7 pi over 7, which means I'm going to stop just short of negative 180, which is going to put me in the third quadrant.
Which, the way that I did it, I got 8 pi over 7.
8
So
pi over 7,
that
which is
would've
just a
been-
little bit more than 180 in the positive direction.
And which is gonna put you in approximately.
Quadrant 3.
That's all I need to know is which quadrant. It's in quadrant 3. Thoughts? Confusions? If you don't like this 140, you don't have to do it this way. You could just keep subtracting 14 pi over and over and over until you get one that's manageable. Or if you don't like it, you could just keep rotating that many times. But I would get confused. I don't want to do either one of those ways. Okay, next one. I'm at negative pi over 3. I want to find a coterminal angle between negative 4 pi and negative 2 pi. Which means I need to get more negative, right? I'm not there yet. I'm only at negative 1/3 pi. I need to get to at least negative 2 pi. So how could I find a coterminal angle? By subtracting 2 pi. What would 2 pi look like this time once I get a common denominator? It's going to be negative 6 pi over 3. You okay with that? Common denominator? And I don't think I've done a good enough job telling you guys. If you are confused, if you're lost, we need to start speaking up, because I mentioned not 90% of what we're fixing to do is based off of what we're building right now, right? So if you don't follow, if you're a little confused, we can explain it, or I can explain it different ways. I just got to know that you're a little confused. Anyways, if I combine these, negative pi over 3 minus 6 pi over 3, this is negative 7 pi over 3. Right, there's an understood 1 here. And that is between negative 2 pi and negative 4 pi. And then how could I find one between 0 and 2 pi? I would need to add 2 pi, which would be adding 6 pi over 3. That's going to give me 5 pi over 3. Negative 1 plus 6.
It's quadrant 4, right?
They are in quadrant 4. All of them will be in quadrant 4. Because they're coterminal.
Oh, yeah.
They all end in the same position.
I thought we're still on the quadrant top of the hill right now.
Find one that's coterminal. You guys go ahead and do this one. Find one coterminal with negative 17 pi over 6.
Negative 5 pi over 6. Yeah.
That's not between 0 and 2 pi.
Oh, I didn't see that. 7 pi over 6.
Yeah.
Did you just ignore the text or something?
We just want to, these are the ones that you need to be able to convert very quickly. Okay? So if you rotate nowhere, that puts you right here. This is 0 degrees. Right? And let's just rotate all the way around in degrees first. So we rotate 30, 45, 60, 90. And you can see where we can draw the triangles later, right, when we get there. I can draw a 30, 60, 90, a 45, 45, 90. Or then there's a 60, 30, 90. But anyways, if we keep going, past 90, I've got to go 30 more. That puts me at 120. 15 more. 135. 15 more. 150. 30 more is 180. $30 more puts me at 210. 15 more. 15 more. 30 more. Am I going too fast? Huh? I couldn't hear what you said. Okay, yeah, okay. 30 more. 15 more. 15 more. And then 30 more puts me back at 360 degrees. 360 puts me back where I started. You okay with those? And so these have to be quick, almost automatic. And the same with the radian measures. So if I rotate no radians, that puts me here. What would 30 degrees be in radians? Well, you see here, 30 degrees is things over 6. So, don't write this down, okay? Don't write this part. Just watch for a second. Every 30 degrees is pi over 6 radians, right? So if I go 30 degrees, I went 1 pi over 6. If I go another 30 degrees, that puts me at 2 pi over 6. Another 30 degrees puts me at 3 pi over 6.
Excuse me, teachers. Youth volleyball forms need to be turned in tomorrow. Youth volleyball forms need to be turned in tomorrow. And on that note, a big congratulations to Aubriella Harrison, who made All-State team in 4A, and Kella McCurdy and Jackson Bruce, who were honorable mention. Congratulations, girls. Thank you.
Well, I did that. I just counted. These are not correct though, because they're not simplified. So like pi over 6, like we started here, 0. 1 pi over 6, that's good. 2 pi over 6. Well, what is 2/6? 2/6 is 1/3. So it's pi, but you did pi. It was a pi, but it didn't look like it. That's 2 pi over 6. This is 3 pi over 6. What's 3 over 6? Four pi over 6. 5 pi over 6 won't simplify. 6 pi over 6. 7 pi over 6 won't simplify. 8 pi over 6. 8 over 6 is 4 over 3. 9 pi over 6. 9 over 6 is 3 over 2. 10 pi over 6. 10 over 6 is 11 pi over 6. Won't simplify. 12 over 6. Yeah, you see where that comes from? See how it makes sense, the 1, 6, 2, 6, 6? Okay? So if you want to fill those out, you can. Those are the correct radian measures. How you want to fill it out, I don't know. I'm not good at making those. I'm not good at making it look neat. I just wing it. a shame, I know. You all hate me, I know. It's fine. And then look at all the ones that I haven't used yet. Those are 45 degrees. Well, so what's 45 in? 45s are in force, right? So if I go 1, this would be 1 pi over 4. Where would 2 pi over 4 be? If I went 45 more. It's here, right? 2 pi over 4, which is pi over 2. Right? I've already got that. Then it would be 3 pi over 4. 4 pi over 4. This is just pi. 5 pi over 4. 6 pi over 4. 6 over 4 is 3 over 2. 7 pi over 4. 8 pi over 4. You guys seen that before? Shown out like that? Hopefully nothing
Not,
groundbreaking.
not explained. Not explained.
Don't die, Cody, don't die.
I cheated so hard.
Okay, the next thing we're going to look at is finding arc lengths. So, what an arc length is just part of the measurement of the outside of a circle. So, if we wanted to find the arc length of the entire circle, what do we call that?
Circumference.
Circumference. What's the formula for circumference?
C equals
2 pi r.
So whatever the radius is, times 2 pi. Well, what's the 2 pi represent? You went all the way around.
radians.
That's
radians.
That's 2 pi radians. Well, the arc length formula is the same thing, except we don't use 2 pi. We just use whatever the amount you rotated is. That's the theta. So if I just wanted half the circle, then it would be S equals pi times the radius. Right? I just flipped them around. This is theta times the radius. It's the same formula. This is just for the whole circle. That's why it's 2 pi.
Is an arc
This is for part of the circle. This would be half the circle. If you wanted a quarter of the circle, it's pi over 2. If you wanted 30 degrees of the circle, it would be pi over 6, right? Depending on how much of the circle you're looking for. That's what you see. It's the same formula. Okay, I'm about to zoom in. I can't read that. For the problem below, theta is a central angle in the circle of a radius r. Find the length of the arc cut off by theta. So this time the theta they give me is in degrees. Degrees are dead to me. I can't use degrees in that formula. It has to be radians. So the first thing I'm going to do is convert degrees to radians and then plug into the formula r times theta, where theta is in radians. So do we remember how to convert from degrees to radians? We spent a little bit of time doing that. Don't remember?
Oh, I think I do remember.
18 degrees. I want to know how many radians that is.
Equals 180 over something.
It can be either way as long as you make them match. Notice I've got degrees on top, radians on bottom. As long as you do that, you're good. You could go it the other way. You could do radians on top, degrees on bottom. It'll still work. If 180 degrees is pi radians, then 18 degrees, I can do this as a shortcut. That would be pi over 10. Anyways, if you didn't know that, cross multiply, right? This would be 180x equals 18 pi. Then divide by 180. So what's 18 over 180? It's 1/10.
Wait, then why didn't we just? Never mind.
So this is my theta. My theta is pi over 10. So to find the arc length, that's arc length is S. It's equal to theta, which was pi over 10, times the radius, which was 8 inches. So this would be 8 pi over 10, which reduces to 4 pi over 5. Right? 8/10 is 4/5.
4/5 pi of an inch.
4/5 pi inches. Or 4 pi over 5.
I don't really like that.
Well, sorry.
What's that box where it's right there? Where it's supposed to top?
Huh? Let's just put the answer right here, which is 4 pi over 5.
Is this canvas?
This is an exact question from your Canvas. Are we okay with this? Everybody get it copied so I can make it a jumbled mess over there. Everybody okay with that? Here's a second one. The minute hand of a clock moves from 12 to 11 o'clock, and the tip of the hand moved 19 inches. Find the length of the minute hand. Give an approximate answer rounded to 2 decimal places.
Moved 11 hours, 19, so.
So it started at 12, and it's went all the way to 11,
12 spots.
which means we have rotated. How many degrees is that, or how many radians is that? Well, if it had went from 12 to 12, that would have been how much?
2 radians.
It would have been 2 pi radians, or 360 degrees, right? But we didn't quite get 360. We're how short of 360?
1/12.
1/12. So what's 1/12 of 360? Or what's pi over?
30. So
So we moved 330 degrees total. 330 degrees.
moved 30.
Now I can't do math with degrees. So I'm going to have to convert this to radians. So what's 330 degrees in radians? This is one that eventually you'll have memorized, hopefully. If not, you can convert it. Remember how to convert it. We just did that. No, I don't remember. I heard. Okay, all right, okay.
That's 11 pi over 6.
So, looking at the formula, I know that the arc length is equal to the radius times theta. What do I know? I know theta. I know how much we rotated. It's 11 pi over 6. What else do I know?
Not
19 inches. What is 19 inches?
the reggie.
The
No,
that how is theta?
19 is not theta. It tells me the tip of the hand moved 19 inches.
that's the arc.
That is the arc length. That means the amount traveled along the outside here is 19 inches.
Then what is theta?
Theta is 11 pi over 6.
That's amount. That's the amount of degrees we moved.
It's in radians, but that's the angle. The angle that was moved is 11 pi over 6. This is the arc length. This is how much was covered. And I'm looking for R, right? Because what's the radius? From the center to the edge, that's the length of the minute hand, which is what I'm looking for. Find the length of the minute hand.
So now you have to solve the thing.
So now solve for R. 19 equals R times 11 pi over 6. which means I'm going to
Divide.
divide by 11 pi over 6. That's fine. I would never write that in my younger years. I would never write divide by fraction. I would multiply by its reciprocal. But I'm getting old. Yeah, I'll just say y'all are right. Yeah, whatever.
Wait, how
It's
do you
less
do
work.
Huh? I would multiply by the reciprocal. You can't divide by fractions. You have to multiply by reciprocal.
6 over 11 pi?
19 over 11 pi over 6.
No. You can't do that.
You can, you calculator.
You can't do it on your paper, but you can.
Fraction. 19 over 11 pi. Do you guys find the pi button?
Yes.
Everybody's found it?
Second and then like
Yeah.
the up. But
Yeah.
Way you can do
I got 3.2988.
a fraction version.
Which they told me to round it 2 decimal places. So 2 decimal places means the 8 tells the 9 to go up. So it's going to be 3.30, which is where they have 3.3. Look at this one. Find the area of a sector with a central angle of 5.89 radians in a circle with a radius of 4.7 meters. So theta over 2 pi times r squared. Do I know theta? I do. It's 5.89 radians. The problem is theta has to be in radians. Oh, guess what? It is in radians. So we're good. So 5.89 radians over 2 pi times the radius. Do I know the radius? 4.7.
So why do you put it over 2?
Because that's the formula for the area of a sector. Not vector, no.
what's the thing it's showing us over here? This one.
Yeah, it's saying this should be the answer. Is that what you got? 65.0551?
I'm about to hit a little heebie.
I haven't typed it in yet.
It's 65.05500105, but it rounds to 5.
Yeah, it would round to that. 0.05505. Yeah, they're just showing it worked out.
65.05.
I don't know why they have 1 over 2.
Yeah, that's probably nice.
I don't know. Just ignore that part. It could be 1 over 2 pi, right? It's just like they left the pi off. Okay, last thing we're going to look at is angular speed versus linear speed. Let me get this correct. Okay. Think about, do you know those old school, they're probably not even allowed anymore because they're probably deemed dangerous. You know those old school merry-go-rounds that they used to have at the playground. And your buddy would make you spin real fast and you're about to fall off of them. You know what I'm talking about? They go, okay, so think about your speed on that merry-go-round. If you were standing right here and you did 1 full trip around, that's one rotation. So say it took one rotation, and say it took you 5 seconds to do it. You did one rotation every 5 seconds. Is your speed the same as if you were standing here and you did one rotation in 5 seconds?
Students, if you have signed up to take the Northeast classes and you need help, you need to go see the Northeast representative in Mr. Bell's office at this time. Thank you.
So think about when you were on the merry-go-round. Where did you want to be standing if you're the one that was on there?
No, closer to the middle.
If you're closer to the middle, you're not going as fast. The closer you are to the edge, you're fixing to fall off that thing. Okay? So, it actually turns out no matter where you're standing, here or here, if you do one rotation in 5 seconds, you would have the same angular speed. It's the number of rotations you do in an amount of time. So no matter if you were here or here, you have the same angular speed. One rotation in 5 seconds. But you would have different linear speeds. This guy's flying compared to this guy, right? So your linear speed is different, but your angular speed would be the same. Okay? So there's 2 different things we're calculating. And that's kind of the breakdown of what they are. So to identify each of them, this is your angular speed, that's an omega, equals theta over the amount of time. So how much did I rotate? So here, one full rotation, that would be 2 pi over time, 5 seconds. Versus your linear speed, it's the distance traveled over time. That's what the S stands for. So the S would be your arc length, right? S, the distance traveled over the amount of time. And they would be different. This one traveled more distance than this one. So it's a higher speed. Okay, so I like making sure you know the difference between them. And now let's do some calculations and then we'll be done. Oh gosh. A saw uses a circular blade that's 8 inches in diameter. It spins at 3,630 RPMs. You guys know what RPM stands for?
Rounds per minute.
Revolutions per minute. Revolutions. So it's how many rotations that saw blade does. 3,630 revolutions in a minute. How quickly are the teeth of the saw blade moving? Express your answer in several forms. Fast. Very good. Any questions? Fast is the answer to that one. So we're looking for the actual speed. So this would be the second formula. This is linear speed. I want to use the same letters they do. They do use V. V equals S over T. But we said S. S is the same thing as the arc length, right? So instead of saying S, we could say theta times the radius. S equals theta times the radius. Y'all remember that from arc length before? So I just substituted that in. So I'm looking for theta times the radius over T. So, what was my theta?
4.
No.
No.
It's the radius.
4 is the radius. So I'll plug that in. What's my time?
Second.
We did 3,630 revolutions per minute. So it's 1 minute, right, is my time. If I do 3,630 revolutions in a minute, what's my theta? If it did 1 revolution, what's my theta?
160. 1 over 6.
No. If I did 1 revolution, 1.
1.
What's my theta? What's my theta? What's my theta? 2 pi. I did 2 pi revolutions. 2 pi. 1 full revolution. 2 pi radians. So I had to do 2 pi 3,630 times. So you're going to multiply 2 times 3,630,
3.
which would be 7,260.
Yeah.
So it's 7,260 pi revolutions.
Times 4.
Times 4. This is 4 what? 4 inches in 1 minute. So if you type all that in, 7,260 pi times 4 inches,
Wait, and then times it by pi.
But
7,260 pi times 4. 7,260 pi times 4. That would be how many inches per minute we were moving. What did you get? What'd you get? What'd you get?
91,231.85066.
So this is whatever y'all wrote. That's correct in inches per minute. Does it tell me what form it needs to be? In feet per second. Do you guys remember doing conversions in chemistry from inches per minute to feet per second? That's what you fix have to do. Okay. Yeah, stoichiometry. Yes.
Oh, I know.
I failed that.
Yeah. And we will pick up with that on Monday. It's not never done it.